What is mathematics? Mathematics has no generally accepted definition. The word mathematics came from the Greek word mathema, which means knowledge, or study, or learning. Mathematics is also described as the abstract study of topics encompassing quantity, structure, space, and change. Mathematics is used throughout the world as an essential tool in many fields, including natural science, engineering, medicine, and social sciences. Carl Friedrich Gauss referred to mathematics as the queen of the sciences. Carl Friedrich Gauss is known as the prince of mathematicians and the greatest mathematician since antiquity. Carl Friedrich Gauss is a German mathematician and physicist who made significant contributions to many fields in mathematics and science. Gauss has had an exceptional influence in many fields of mathematics and science and is ranked among history's most influential mathematicians. Johann Carl Friedrich Gauss was born on 30th of April 1777 at Brunswick, Principality of Brunswick-Wolfenbüttel. Gauss died on 23rd of February 1855 at the age of 77 at Göttingen, Kingdom of Hanover, German Confederation. Gauss was a child prodigy. In his memorial, Wolfgang Sensorius von Waltershausen says that when Gauss was barely 3 years old, he corrected a math error his father made, and that when he was 7, he confidently solved an arithmetic series problem faster than anyone else in his class of 100 students. Gauss' intellectual abilities attracted attention of the Duke of Brunswick, who sent him to Collegium Corallinum, which he attended from 1792 to 1795, and to the University of Göttingen from 1795 to 1798. While at the university, Gauss independently rediscovered several important theorems. His breakthrough occurred in 1796 when he showed that a regular polygon can be constructed by compass and straight edge if the number of its sides is the product of Fermat prime and a power of 2. This was a major discovery in an important field of mathematics. Construction problems had occupied mathematicians since the days of the ancient Greeks, and the discovery ultimately led to choose mathematics instead of philology. The year 1796 was productive for both Gauss and number theory. He discovered a construction of hexadecagon on 30th of March. He further advanced modular arithmetic, greatly simplifying manipulations in number theory. On 8th of April, he became the first to prove the quadratic reciprocity law. This remarkably general law allows mathematicians to determine the solvability of any quadratic equation in modular arithmetic. The prime number theorem conjectured on 31st of May gives a good understanding of how the prime numbers are distributed among the integers. Gauss also discovered that every positive integer is representable as the sum of the most 3 triangular numbers on July 10. On October 1, he published a result on the number of solutions of polynomials with coefficients in finite fields, which 150 years later led to the Weyl conjectures. In 1840, Gauss published his influential Dioptrics on Tersotungen, in which he gave achieved the first systemic analysis in the information of images under a paraxial approximation. In 1854, he became an associated member of the Royal Institute of the Netherlands. When that became the Royal Netherlands Academy of Arts and Sciences in 1851, he joined as a foreign member. In order to clarify the foundations of mathematics, the field of mathematical logic and set theory were developed. Mathematical logic includes the mathematical study of logic and the applications of formal logic to other areas of mathematics. In the Principia Mathematica, Bertrand Russell and Alfred North Whitehead advanced the philosophical program logicism and attempted to prove that all mathematical concepts, statements, and principles can be defined and proved in terms of symbolic logic. In 1847, George Boole formalizes symbolic logic in mathematical analysis of logic. He later regarded it as a flawed exposition of his logical system and wanted an investigation of the laws of thought on which are founded the mathematical theories of logic and probabilities to be seen as the mature statements of his views. Contrary to widespread belief, Boole never intended to criticize or disagree with the main principles of Aristotle's logic. Rather, he intended to systematize it, to provide it with a foundation, and to extend its range of applicability. Boole's initial involvement in logic was prompted by a current debate on quantification between Sir William Hamilton and Boole's supporter Augustus de Morgan. George Boole was a largely self-taught English mathematician, philosopher, and logician. Most of his short career was spent as the first professor of mathematics at Queen's College, Cork in Ireland. He worked in the fields of differential equation and algebraic logic and is best known as the author of The Laws of Thought in 1854, which contains Boolean algebra. Boolean logic is credited with laying the foundations of the information age. George Boole was born on November 2, 1815 in Lincoln, Lincolnshire, England, and he was died on December 8, 1864 at the age of 49 at Ballinstimple, Cork, Ireland. Boole's first published paper was Researches in the Theory of Analytical Transformations with a special application to the reduction of the general equation of the second order, printed in the Cambridge Mathematical Journal in February 1840. In 1841, Boole published an influential paper in early invariant theory. In 1844, Boole's paper on a general method in analysis won the first gold prize for mathematics awarded by the Royal Society. It was a contribution to the theory of linear differential equations, moving from the case of constant coefficients on which he had already published to variable coefficients. The innovation in operational method is to admit that operations may not commute. In 1847, Boole published the Mathematical Analysis of Logic, the first of his works in symbolic logic. He was awarded the Keith Medal by the Royal Society in Edinburgh in 1855. Boole completed 2 systematic treatises on mathematical subjects during his lifetime. The treatise on differential equations appeared in 1859 and was followed the year by a treatise on the calculus of finite differences, a sequel to the former work. In 1857, Boole published the treatise on the comparison of transcendents with a certain applications to the theory of definite integrals, in which he studied the sum of residues of rational functions. Set theory. Set theory is the branch of mathematics that studies sets or collection of objects. In 1908, Ernest Zermelo axiomatizes set theory. Ernest Zermelo is the ancestor of modern set theory. Ernest Friedrich Ferdinand Zermelo was a German logician and mathematician whose work has major implication for the foundation of mathematics. He is known for his role in developing Zermelo-Fraenkel axiomatic set theory and his proof of well-ordering theorem. Ernest Zermelo was born on 27th of July, 1871 in Berlin, German Empire. Zermelo died on 21st of May, 1953 at the age of 81 at Freiburg im Breisgau, West Germany. Zermelo began to work on the problems of set theory under Hilbert's influence in 1902, published his first work concerning the addition of transfinite cardinals. By that time, he had also discovered the so-called Russell paradox. In 1904, he succeeded in taking the first step suggested by Hilbert towards the continuum hypothesis when he proved the well-ordering theorem. This result brought fame to Zermelo, who was appointed professor in Göttingen in 1905. His proof of well-ordering theorem, based on the power set axiom and the axiom of choice, was not accepted by all mathematicians, mostly because the axiom of choice was a paradigm of non-constructive mathematics. In 1908, Zermelo succeeded in producing improved proof making use of Dedekinds' notion, the chain of set, which became more widely accepted. This was mainly because that same year, he also offered an axiomatization of set theory. Zermelo began to axiomatize set theory in 1905. He published his results despite his failure to prove the consistency of his axiomatic system in 1908.